In this video, we're diving into the world of ARP and RARP protocols. These protocols handle the critical task of address resolution between IP addresses and MAC addresses. Imagine you have two devices. Let's call them Device 1 and Device 2. Device 1 knows the IP address of Device 2, which is 192.168.1.10, but it needs to find out its MAC address to communicate directly. So Device 1 sends out an ARP request. This request asks, who has the IP address 192.168.10? Tell me your MAC address. This video will explore how this process works and why it's essential for network communication. Let's understand what ARP and RARP actually are. ARP, which stands for Address Resolution Protocol, is a communication protocol used to discover the link layer address, such as a MAC address, associated with a given internet layer address, typically an IPv4 address. ARP is essential for data transmission on local networks. It operates at the link layer, which is layer 2 of the OSI model. Now let's talk about RARP, or Reverse Address Resolution Protocol. RARP is used by a device to request its IP address from a server when it only knows its MAC address. This is particularly useful for diskless workstations at boot time. However, RARP has largely been replaced by more advanced protocols like DHCP and BOOTP. Let's walk through the ARP process step by step. Host A with the IP address 192.168.1.5 and MAC address AA:BB:CC:DD:E:FF needs to send data to host B, which has the IP address 192.168.1.10, but host A doesn't know host B's MAC address. So first, host A broadcasts an ARP request to all devices on the local network, asking for the MAC address associated with the IP address 192.168.1.10. Host B recognizes its IP address in the ARP request and responds directly to host A with its MAC address. Finally, host A caches the IP to MAC mapping in its ARP cache and sends the data directly to host B. Let's examine the structure of an ARP packet. An ARP packet contains several important fields. First, we have the hardware type, which indicates the type of network hardware being used. For Ethernet, this is typically 1. Then there's the protocol type, which specifies the protocol for which the MAC address is being requested. For IPv4, this is 0x0800. Next, we have HLEN and PLEN, which represent the lengths of the hardware and protocol addresses, respectively. For Ethernet and IPv4, these are 6 and 4 bytes. The operation code indicates whether it's an ARP request or an ARP reply. Common ARP operation codes are 1 for ARP request, 2 for ARP reply, 3 for RARP request, and 4 for RARP reply. After that, we have the sender hardware address, SHA, and sender protocol address, SPA, which contain the MAC address and IP address of the sender. Finally, there's the target hardware address, THA, and target protocol address, TPA, which contain the MAC address and IP address of the intended recipient. Now let's explore the RARP process. A diskless workstation, which only knows its MAC address, initiates the process. First, the workstation boots up and broadcasts a ARP request, asking, "What is my IP address?" The RARP server, which maintains a database of MAC to IP address mappings, receives the request. The RARP server looks up the MAC address in its database and finds the corresponding IP address. Finally, the RARP server responds directly to the workstation with the associated IP address. The workstation then configures itself with the assigned IP address, allowing it to communicate on the network. Let's talk about ARP Cache Management. The ARP cache is a temporary storage of IP to MAC address mappings on a host. It reduces network traffic by avoiding repeated ARP requests for the same IP address. ARP cache entries have a time to live, or TTL, which is typically between 2 and 20 minutes. The ARP cache can contain both dynamic entries, which are learned through ARP, and static entries, which are manually configured. However, the ARP cache is vulnerable to ARP spoofing and poisoning attacks. Now, let's look at some commands for viewing and managing the ARP cache. On Linux and Mac OS, you can view the ARP cache using the command ARP. To add a static ARP entry, use the command sudo arps followed by the IP address and MAC address. And to delete an ARP entry, use the command sudo arpd followed by the IP address. Let's address the security concerns associated with ARP, specifically ARP spoofing attacks. In an ARP spoofing attack, an attacker sends fake ARP replies to victims on the network. These fake replies contain incorrect IP to MAC address mappings, causing the victims to update their ARP caches with the attacker's MAC address. As a result, all traffic between the victims now passes through the attacker, who can eavesdrop, modify, or block the communication. To prevent ARP spoofing attacks, you can use static ARP entries for critical systems, implement packet filtering on switches, deploy ARP spoofing detection tools, use encrypted protocols such as HTTPS, SSH, and VPN, enable port security on network switches, use DHCP snooping and dynamic ARP inspection, implement network segmentation, and monitor the network for suspicious ARP traffic. Let's summarize what we've learned and the evolution of address resolution. ARP maps IP addresses to MAC addresses, while RARP maps MAC addresses to IP addresses. ARP is critical for local network communication, and the ARP cache optimizes network performance. However, security concerns require proper ARP management. ARP was introduced in 1982, followed by RARP in 1984. Later, BootP and DHCP replaced RARP in 1993. In 1998, Neighbor Discovery was introduced in IPv6. In modern networking, we have alternatives like IPv6 Neighbor Discovery Protocol, NDP, Secure Neighbor Discovery, SEND, DHCP for IP address assignment, and software-defined networking (SDN) approaches. For further learning, refer to RFC 826 for the ARP specification, RFC 903 for the RARP specification, RFC 4861 for Neighbor Discovery for IPv6, Wireshark for ARP packet analysis, and various ARP security tools and best practices. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.